Welcome to AI, Government and the Future, a podcast by Corner Alliance. We explore the intersection of artificial intelligence, government and the future. We work with government to create results. We ignite your agency's mission by helping you to design and implement high-impact and innovative federal programs in AI, broadband, cybersecurity, public safety, and more. Being a government ally is at the core of all we do.
All right, welcome back to AI, Government and the Future. I'm your host, Max Romanek. Today, we are joined by Lennart Heim, a distinguished research fellow at the Center for Governance of AI, also known as GovAI. Lennart leads the compute governance work at GovAI, focusing on how computational resources can influence and shape the trajectory of AI development. His expertise includes advising top tech companies and governance, particularly in the US and the UK, on policy and technical aspects of AI. Throughout his career, Lennart has explored the roles of compute for advanced AI systems and its implications on security and governance. In today's conversation, we'll uncover the nuances of compute governance, the balance between innovation and regulation, and the future of international cooperation in AI policy. Join us as we navigate these complex topics with Lennart Heim, whose insights are helping shape the future of AI governance. Welcome, Lennart.
Thanks so much for having me, Max.
Just as a means of going and getting us started here, could you share with us a little bit about your experiences and how they have shaped your current perspectives on AI governance? Specifically, what inspired you to focus on the computational compute aspects of AI systems?
I think it's not necessarily a surprise because I come from a technical background. So I studied computer engineering. I always wanted to be a computer engineer or software engineer, building things. This was initially the inspiration and aspiration. But then eventually I learned about AI and AI governance and the problems everything related. I was like, oh, that seems interesting. Maybe it's like some kind of sub-niche here. So I think that's the field which I've been trying to navigate over the last couple of years. Like coming from a technical background, I'm claiming I do understand some of the technical stuff, but I also want to then bring them into the governance and the policy discussion and how we can manage these kinds of risks. And yeah, I think this is basically my niche. I sometimes like to call it technical AI governance, or in my particular case, focusing on compute and AI. What is the role of the computing hardware which we need for AI?
That's a great lead into my next question. You've mentioned extensively in your research about the exponential increase in computing power and its role in AI advancements. Can you predict any sort of strategic allocation of compute resources and how that'll evolve over the next few years, the sort of impacts that you see potentially emerging there?
Yeah, I think it's a discussion which keeps on going, right? Like I talked about an exponential a couple of years ago. People even talked about it before me. But I think the exponential in terms of AI progress, AI capabilities, I think we've all seen it happening in real time to some extent with ChatGPT and more. And I'm focusing on underlying resources, which also been growing exponentially to something we like to drive these trends. And I think what we see right now happening in the world, I would just usually point people to the NVIDIA stock and just name an example of like this company supplying these AI chips to say like, there was something going on there, right? And like, at least since ChatGPT, people woke up to the importance of compute, to the importance of AI chips for AI progress. And if you follow discussion right now, I think maybe the new hot topic here is everything around data centers. Like everybody now wants a data center. Everybody wants high performance computing. Everybody talks about sovereign AI, sovereign computing clusters. And I think this just adds another dimension to it, right? And I guess that's like the new trend we're seeing, more and more nations thinking about data centers to host not a couple of chips, thousands, tens of thousands, hundreds of thousands of these chips, and where we put these data centers, and with it also all the geopolitical considerations which come with it.
So focusing a little bit in on some of those geopolitical considerations, there's sort of a balancing act, it seems, that we want to spur innovation. We want that to be transparent, but then historically, the way that technological competition works, that is not usually a very cooperative sort of endeavor. Have you seen any sort of international frameworks or anything on the international level that's doing a decent job of balancing those tensions?
I think everybody's coming up with like new measures to balance these kinds of things. I must say, me personally, within my capacity as a researcher, I focus a lot of the risks. So whenever I say here, and I only talk about the risk and all the bad things which can happen about AI, this does not necessarily mean I think that's the default way it's going to go. This is just like, this is my job. I just focus on the worst things. If it goes well, that's great. If I'm obsolete, that's great. I wish it's going to be this way. So I can always talk better about the risk than about the benefits. I do think compute is an interesting topic in that sense, because, for example, I talk about managing access to compute, these resources, about export controls and more. But it's fair to say that the majority of all nations in the world don't even have access to these computing resources to participate at frontier AI research, to even participate in some meaningful way within AI. And this is definitely a discussion which I see every single time when I'm like more in the international context there. When I talk about like we should shape it, we should give more compute to the good guys and less to the bad guys. In the international context, this does not always work this well, because there's a bunch of people like, we don't even have any access. We cannot even have the discussion about how we should steer it within our country. We do not have the means of doing so. And then I would just in general say there's like more international things going on. I think the most interesting things right now are the AI Safety Institute with the UK spearheading this effort, then having a partnership with the US. And I think that's like one really exciting avenue when at least when we talk about AI safety. But again, we have a forum on the UN, we got the OECD working on this. All of these are parallel efforts, they have some overlap. Everybody has like their small own niche where they're trying to focus on, because they're simply not the field of AI anymore. It's just way more beyond this, in particular when we talk about a general purpose technology.
That makes a degree of sense for sure. I guess drilling down then into some of the more specifics around governance models, you talk a lot about detectability in your research as one of the key attributes to make compute governable. Can you elaborate a little bit on the technological and regulatory measures that could enhance transparency in AI development without compromising the proprietary information and security?
To make the argument for compute, I think it's like probably the best way to have like an input-centric view on AI systems, where we just say, what are the things we need to develop AI systems? And naively, you can say there's the so-called AI triad, where we say, well, we need data, where we train the systems on. We need compute, which is crunching numbers. And we need the algorithms, the neural network architecture, which describes what we eventually do with the compute and how we train on these types of data. And then when we talk about detectability here, then data and algorithms are like a couple of bytes on my computer or like on somebody's server. This is not really detectable, right? And I can literally just copy and paste this right now and just have thousands, millions, billions of duplicates at once. So, and again, compute in contrast to this has an underlying feature. It's an underlying chip. It's a physical resource here. So again, even just for a single chip here, at least it's a physical resource, which is something we make the governance more interesting and more feasible. But if we go further, if we like, for example, talk about the let's just call it the frontier of AI development, these general purpose systems, these ChatGPT systems, which you see in the world, then we talk about them needing thousands, tens of thousands, hundreds of thousands of these chips for being trained, and similar amounts actually for being deployed. If you serve millions of users, right? These are like huge computational loads, and everybody can experience this themselves. When you ask ChatGPT a question, it takes a bit because it's crunching these numbers. You don't get an immediate answer there because it's literally running in the background on a couple of dozens of GPUs, the computation there. And I think this just makes the argument for the detectability. We have a physical resource. For the frontier development, we need tons of it, lots of it. It needs to be housed within a data center. So I roughly know what's going on there. And from a governance perspective there, for example, my focus, where I mostly focus on the risks stemming from these general purpose AI systems, it makes my life to a large extent easier because there's only like a handful of actors who have access to sufficient computing power. So instead of like being worried about any random actor or like a terrorist group training really advanced AI system in a cave, I'm not too worried about this simply for these arguments which I was just making, right? This makes then like the AI governance problem significantly easier.
So then do you also concurrently see roles for technologies like blockchain and everything for enhancing transparency and accountability, given that there is that sort of physical nature and something trackable?
I'm probably skeptical about like 95% of applications of blockchain. I would generally just like start with, what's the problem? What are we trying to solve here? What's a nice, interesting application for blockchain, which I couldn't like imagine for AI governance, is like a lot of times we want to put something out there in the public in a verifiable way and everybody can see it. Well, this is where a blockchain could help. Again, do I necessarily need a blockchain? I think we could maybe literally start with a piece of paper and we just have an international institution around it. Maybe we also go for technology solutions. A lot of times I like to say we trust math more than we trust people. And that's nice. We can leverage these kinds of features. So I generally go there. And again, my job's like use technical tools to solve a technical problem. This will never be self-sufficient. We always need the policy, the people, and again, the handshaking all around it. But it can make our life easier, right? I can trust other nations more if they have like an attestable and verifiable way to give like credence to their claims, right? For example, if they claim, hey, look, I trained my system, I did these evaluations, and it's not dangerous, and I can show you the results there. Sure, put it on a blockchain with some fancy method. I think some people can come up with some ideas there. And this might be one way how you want to go about it. And again, then blockchain just being one of the many tools you can then leverage for, again, trusting the math and not trusting necessarily the people.
And have you seen any specific emerging tools that you think are very promising in that space?
What I'm generally excited about is we see in the EU AI Act and we see in executive order this idea of a so-called training compute threshold, which basically the executive order says if you train a system which is bigger than 10 to the power of 26 operations, so you need more operations to train the system, guys, you got to give us a heads up, right? And then you got to fill out the survey. And I think this is like one way right now we can just probably trust these actors for doing it so, but maybe in the future we want to verify these types of compute usage and more. And this means where cloud providers, compute providers, whoever owns this hardware could play an important role for doing this. So like, I think that's like an exciting barrier of like verifiable compute usage on the high level. But you can go even further where like you prove certain properties of the system. Again, we are right now having a hard time. What are the properties I'm like more interested in, which are more worrying, which are good? But in the future, if we have like more research, we could, for example, say this, we're like, oh, you've done X to your system. Doing X to your system is a de facto standard for making it safe. And that's the way of proving it. What we see right now is we have no clue what we even talk to, right? If I talk to ChatGPT, if I talk to Claude, if I talk to Gemini, I talk to a website which talks to an API. Could be one system, could be dozens of systems. Who knows? I'm talking the next day to the same system. And just having some verifiable ways of doing these kinds of things, this would be helpful.
So I guess sort of riffing on that then, from your perspective, where do you see the sort of long-term societal implications of how we allocate compute today?
I think it's become a more important question over time. So we've seen already over the last few years, I think a bunch of people always talk about the compute divide between countries and within countries. I already touched upon this idea of like between countries, right? There's just like some companies and countries who have like way more access to these kinds of resources. But also within countries, me and some colleagues did some research on like the compute divide between academia and industry. And what we just see right now is like all of these big models that cost tens of millions, maybe in the future billions, to just train this in computational resources alone. Not even paying the salaries for the researchers, right? This means academia simply cannot compete with these kinds of systems. Doesn't necessarily mean academia should compete to build these kinds of systems, but maybe academia wants to do more compute-intensive, compute-heavy research. This means we've seen in the UK the future of compute review and the allocated high-performance computing they now want to build with a lot of GPUs and AI accelerators to give access to researchers and startups. We see similar movements in the US with the National AI Research Resource, the NAIR, where they talk about like, we need to give our research more access to compute. So this generally, there's like this idea of going around, like in general, also when you're like Silicon Valley, compute as this currency of the future. And if it's a currency of the future, I probably want to make sure there's like some fair shared access. I do say it's still not a question how we should best go about it. Because nobody's like, there is no benefit in just having access to compute. What you're eventually interested in is like AI systems and the capabilities of these AI systems. So if I can just like share the AI systems and the benefits of it, do I need access to compute? Not necessarily. But I think what's the more interesting component here is like the sovereign component. It's not that the whole world wants to be dependent on US companies. It's like, wait, if I'm going to use like a large language models, maybe like be it for intelligence servers, like any national servers, I can't maybe use American compute. I can't use American models for these. Maybe that's part of the interest, why they want to build their own sovereign models and their sovereign computing systems. But I think all of this is still remains to be explored. And I would call on all economists to a little bit more research here, because I think right now it's more of a meme and vibe than actually strong, rigorous research, which makes the argument that we should like share compute all across society.
In addition to economists, where do you see the role for policymakers sort of internationally coming into this? It seems like there's an opportunity potentially to at least catch up with some sane policy, but what sort of role do you think that looks like, and what sort of policies would be sane or at least forward thinking in an environment like this?
I mean, it's definitely forward thinking, just like for every nation to think about what should your role in AI be. And I think then, of course, I'm probably a fan of cooperation, where just like not everybody needs to build on a sovereign model, but maybe you need it for your language, maybe you like collaborate with some partners. And again, I want to start with like, what do I need from AI? Which capabilities, which deployments, which applications I want to use? And then backchain it from there. And then you can say something about the compute usage. Or you can say something, should I just contract it? Should I buy it? Should I rent it? Should I like delegate it? Should I build on my own? And based on these decisions, you can then decide, should I build my own big supercomputer cluster or not? I think that's part of the ongoing discussion there. This is more on the allocation angle and like giving more people compute, maybe like feeding forward more beneficial research, more research that produces public goods, right? This is part of the reason why we like academia. They do research which academia doesn't do. And this does not necessarily need to be computer intensive. On the other side, I think it's important to say when we talk about the international context here, the international context is that, for example, the US and their allies, they do have export controls on the semiconductor manufacturing equipment and related components which feed into this, and also the AI chips. So there's like certain AI chips right now which are not allowed to go to China. And this is, of course, also of international importance because they're using it as a tool to cutting them, China, off from the future of AI to some extent by saying like, well, if we don't give them these chips, which are right now pretty good and like part of the thing you need to participate at frontier, you cannot. So again, this is also part of the international discussion there. It's about like restricting access, but also about giving access depending which actor you are.
It definitely seems like there's a quite a balancing act that policymakers are needing to engage in. On the one hand, they want to encourage innovation, but they also have an imperative to prevent misuse and overreach. Things like surveillance and autonomous weaponry come to mind with that overreach. Have you seen any sort of specific policy interventions that have come in to try to balance that act? How do we control for the really scary stuff while not stifling innovation at the same time?
I mean, it's always the balance you need to strike for all of these kinds of things. How can we go about this? I think right now, when you look at AI policies, lots of this motivated by national security risks. We talk about models which give like maybe adversaries certain cyber capabilities. Then there's been like lots of fuss going around giving them access to certain capabilities to produce dangerous bioweapons, anything along these lines. And then when you talk about national security risk again, then this relates to export controls, anything else along these lines. Then the other way how compute is being used, just as a tool to, again, when we talk about executive order and the UAI as a classifier for which system should I pay more attention to. I would always say we right now, taking a look at GPT-4, Claude 2, 3, and Gemini, and be like, seems like these systems are not trying to take over the world yet. Seems like these systems do not pose like any significant risk. But what about the future systems there? And I just want an approach which says, we don't know yet. Let's take a look. Let's lose some precautionary principle here and take a look at these kinds of systems. And again, I think my focus here is mostly on these general purpose AI systems, which require like tons of compute to use them. When we, for example, talk about autonomous weapons and all these kinds of things, all of these discussions get harder anyways, because you enter the military domain. We have and been having for years lots of discussions about autonomous lethal weapons, where we have the usual play. There's like some countries which sign it, and the most important countries who should sign it are not signing it. But more importantly, these systems usually do this on device processing when we have a drone there. So they do not run the local GPT-4 model. They just run some local computer vision algorithm to do these actions there. So again, I think the role for these more general purpose models in military is like still to be learned more, where eventually do they play a role. And they are distinct from these more narrow applications when we talk in this case, for example, about facial recognition software or drones or autonomous weapons and these kinds of things. In general, I'm more skeptical that the leveraging of compute here, at least the quantity of compute, is not the key deciding factor of what you can do. There we need, again, many other policies processes happening at the same time to make more sane and better decisions.
Okay, so it's less of a risk of that exponential curve on compute going up, making the edge network devices and IoT stuff smarter and smarter and smarter. That's not really the sort of criticality of the risk that you're thinking is at play here.
I think so. It's a different research you made where we see similar trends, totally. But again, we just have some hard limits, because if we look at these trends for large language models, chips are getting better over time, roughly doubling every 2 years, famously quoted as Moore's law. This means, sure, this is the same for the drone, right? My drone in 2 years is roughly twice as good as before. But when we look at the frontier, it's not they get better chips, but they also just throw more chips at these problems. And this is the bigger driving factor here. And for the drone, there's a limit. You cannot just simply throw more chips at this. When we talk about these chips which are export controlled, be the NVIDIA A100, H100s, these chips eat like 500 to 800 watts. You cannot put this on a drone. This thing is going to be out of battery before it even like takes off, right? So we have like complete different problems there. I think where it gets more interesting is like when you look at like strategic decision making, when these models help you to identify targets for intelligence. Again, this is where they help this general purpose ideas, where like I process a bunch of text, identifying targets, identifying strategies, and I guess way more. I'm also just simply not read up on how these things are being used in a military context, and I probably don't know the majority of it.
It certainly echoes a lot of the concerns that I deal with day in and day out with my clients, where they get concerned about the headline grabbing stuff, AI on a, autonomous weapons system or sentient AI. And I have to walk them back a lot and say, it's probably a little scarier having an incredibly intelligent algorithm that isn't conscious, that uses a big data set that might know more about you as a person than you really understand for yourself, because it's a better pattern recognition system than you are for your own life and operations and everything like that. And trying to distinguish realistic risk from fear of the unknown, and there's a lot of unknowns associated with this. That becomes a big deal in our work with government clients and trying to provide them good advice on what do you actually need to be concerned about here? What are regulatory and policy tools at your disposal? Because you don't want to have them going after, well, we want to make sure we don't have a sentient AI. is that even the risk that you really want to be controlling for? Probably not, based on how this stuff goes. And so I think that's where conversations like within your space around compute resources, that's much more tangible for them. They understand more about a regulatory regimen or a governance regimen for something tangible like that, because it's a physical asset. They can have something to say about transaction, trade, control, all of that sort of stuff. Whereas some of these other more high-tech applications that are not necessarily in their policy wheelhouse, that gives them a little bit more pause and trying to unpack what's real from what's a science fiction novel. That really, I think, becomes a huge focus for people in our line of work for sure.
What you were just saying is like also partially just like this idea of saying it's a physical resource. This means like some of the governance tools we have, we can really use it. So we can physically control AI chips and the flow of it, at least one is trying to. What do we do with software? There it always just gets way harder. There's like all of these ongoing discussions about publicly releasing model weights. Is our country even allowed to use this, right? Do they have like the legal backing for doing these kinds of things? And practically, how you're going to go about and how you're going to enforce this? And these are new challenges which just come with this digital technology. So like I'm sometimes worried that people just always long for compute because it's like you can use already applicable resources there. And it's like this physical, tangible thing you can think about. Whereas other tools, again, just we haven't figured out yet how to best go about this, but they might be equally promising or additional layers of defense we might want to use there. This is just where we need to learn. Like again, with AI, it's just like really, really hard because it's progressing so fast.
Absolutely. Bringing that right down into something pretty concrete. If limiting compute resources is a form of governance, have you encountered ethical considerations with pulling that lever? What happens ethically in terms of controlling access to those sorts of things?
That's a good question. I think you basically make decisions about who's participating in AI research and who isn't. And it's to some degree what I like to sometimes say, it's a blunt tool. It's not really, I'm just like, oh, you don't get it and you get it. It's not like wherever I want to like more targeted tool, I'm just like, I do like this field of research. I do like using facial recognition systems to imagine a good use case, but I don't want you to use it to discriminate against minorities. Can me with allocating compute decide on this? Not necessarily. The best way I can do it there is like, oh, there's this actor who I know has a track record of doing bad things and discriminating, or the state doing this. And there's the other actor who doesn't have this track record and have like the appropriate safeguards in play. So the best way to think about it is like compute is probably more of your enforcement node and sometimes maybe even your last resort. We have, particularly for domestic governance, other tools in place to make sure people do, again, the good things and not sincerely the bad things. Does this mean I need to like use my compute harpoon in that sense, like cut them up? No. But if they violate it over and over again, I don't see any other resource, then we go about it. It's similar how you can think about websites, right? If you put illegal content on your website, if you put on your website how to build a bomb, you will probably get a letter from somebody and telling you, hey, can you please take this down? If not, you get a fine. You probably get a fine anyways. If he can't track you down, if he can't find you, law enforcement at some point is either going to knock at your door or knocks at the door of the service provider, of the web hoster, and she's like, hey, whoever hosts this website, please take it down. It's not allowed. So again, we have these first levers first, which we're going to be using, which we usually use for most governance nodes, particularly in domestic context. I think in domestic context, compute is mostly used as like this idea to get visibility, not to enforce. You can use it as a last way to enforce. And that's just something what we see with these export controls. We had end-use controls initially, where we're saying there are certain actors which are linked to the Chinese army. We don't want them to get access to these resources. But then we were selling it to somebody else and they still ended up in their hands. And you're just like, hey guys, it seems like we can't sell anything because it always ends up there where we don't want it to end up. Right. And then you unfortunately have to go for this more blunt tool and more broader tool for compute. Again, if we literally talk about the allocation of compute here, there's lots of ways how you can use compute for visibility and for verification, where I think it's less blunt, right? Where it's less about like giving it to somebody and taking it away. And I think there's like a bunch of interesting avenues there.
And I mean, is that even really a feasible option? I mean, I understand all of the mechanisms and arguments around blocking access initially, but once access is there, once supercomputer cluster is built, it's pretty hard to take it back without some sort of physical intervention at that point. I mean, there's no way you can regulatorily turn it off. It's not the same thing as necessarily going to a service provider with a warrant and saying you must take these actions. I mean, you're probably dealing with a sovereign government who politely will tell you to go pound sand.
Absolutely. I think like you're hitting on this like important point. When I want to have impact with like cutting off chips, right, I need to basically cut them off right now to have an impact in the future because you don't feel this immediate impact there. And then again, I have like, again, this blunt impact literally over time. They might only do one bad thing at a single point in time, but we just say like, no, not at all. You never do it. And one good way to think about this is like, there's a difference between selling chips, giving somebody the physical resource, and giving somebody infrastructure service, cloud tools. Then I sell it to you on demand. And to some degree, this is the way better governance node because I can just cut it off at any single point in time if I wanted to. So if I detect a violation, I can literally cut you off on the chips. I don't need to go in and steal the chips back. So it gives you this promise there, and you can be more targeted where you just say like, I do, for example, we had papers proposing know your customer regimes. If somebody uses a ton of compute, maybe quickly ask who they are. Does this give you all of the insurance you need? Not necessarily, but you can check on certain things. And again, if you believe in a hypothesis, which is the scaling hypothesis, and like what we've seen there is like more compute means more capable systems, I can also roughly say if an actor is only using, let's just say, tens of millions of compute, I'm like, okay, that's fine. They're not building a frontier model. But if there's an actor using $1 billion, I'm like, oh, wow, who are you? What are you doing there? Can I ask some questions, right? And given that we talk about these massive amounts of money here, we don't talk about a KYC regime, which we have with banks where you need to check on everybody, which is a big hassle. We talk about checking on a couple, maybe on a handful of actors and asking, what are you doing here? Can you just give us a brief answer? And who are you? And then you can detect if someone's just trying to set up a shell company and trying to circumvent certain rules. So I think the cloud providers here, they give a lot of promise for acting as this intermediary for checking on compliance and seeing what's going on there.
Definitely an interesting set of policy and governance tools in operation there. And I can't help but be struck by the disconnect between what a sovereign actor would be looking at and what academia, private sector, all of those sorts of things. Because, they're able to patronize Amazon Web Services, Microsoft Azure, all of those different cloud platforms just fine. And then, yes, you have a much more robust regulatory regimen that you can execute there. But the sovereign level, you are picking winners and losers with those export controls. And, we're picking winners and losers in a field that we are sort of at the nascent state of figuring out what its full capabilities are going to be. Very interesting and a lot of tension. It's sort of picking out what the geopolitical landscape over the next couple of decades is going to look like. And we're having to make those decisions now without the full information in front of us around what that's going to look like.
That's part of the key challenge here, right? It's when people ask about what is the ideal international governance regime? How do we get there? I was like, we already started. We don't start from a blank slate here. There are existing geopolitical dynamics which go beyond AI, right? There's like more than just AI, even though, we sometimes all I think about is AI. There are more things going on there which it plays a role. And I think it's fair to say, majority of all geopolitical contexts, most decisions are being made without being with AI in mind. But then also just this idea of just like, if you want to use export controls, you want to have an impact 3 years down the line, you kind of need to act now. And this is just a tricky decisions you basically need to make there.
Has there ever been an instance in history where we've encountered a similar sort of problem like this, where most of the regulatory controls that we want to use are best not targeted at a nation state or another governmental actor, but from a tech perspective, all the controls have to happen through this other layer where we're really talking about access. And then there's only a few areas where access could even be had. Like the gateways are pretty easy to guard because once you're inside the walled garden, fine. But outside the walled garden, those walls are sort of insurmountably high.
I'm going to name like a typical example, which in the case just like maybe nuclear weapons. I think sometimes people try to make the analogy between uranium and AI chips. And again, it's like wrong on a bunch of levels, but I think on like some levels, like, oh, AI chips are not per se bad. So it's not uranium. For uranium, we basically say highly enriched uranium is used for weapons. The low enriched uranium used for nuclear energy. For chips, we maybe can say something same. It's like 1,000 chips are fine. 1,000,000 chips, we get a little bit nervous here, right? The difference here is just, again, like the common thing is like, well, the thing can be used for energy and for weapons. For AI, I think it's even more complicated because it's even more general purpose than in this case, right? And for highly enriched uranium, you can say you either build a weapon, which is mostly going to be used for bad, whereas for AI systems, not that the most capable AI systems are the most bad systems, those are the most capable and the most useful, and they drive the economy the most forward. So the categorization hinges there to a large extent. But we have, to some degree, successful international non-proliferation regimes around the idea for uranium with verifications and everything, and like way more built around this. And with compute, to some degree, I think it's fair to say enriching uranium and finding uranium is probably easier than it is to build your own AI chips. I think it's fair to say when we talk about the most advanced AI chips, it's probably the most complex product we as humanity have ever created. This means we have only one company in the Netherlands, ASML, producing the machines, which go to TSMC in Taiwan and a couple of other locations, which produce have a 90% market share of all the cutting edge AI chips. Then they use for the AI chips like this high bandwidth memory, which is coming from 2 companies. This then needs to be packaged, which currently only TSMC does. We talk about here some know-how, which not a single nation is alone trying to replicate. So like to some degree, like producing AI chips is like significantly harder than producing like enriched uranium. And this is one way how we can use this governance node. But again, of course, it goes way more around because the two of us, we're both using AI chips. We just don't use maybe the most cutting edge, but we have AI core processors on our phone, on our laptop, and everywhere. To that extent, it's like already a commodity, which is already all around us. The only difference we try to draw here is just like with the performance and the quantity you use there. And then there we like trying to draw a line there. There's at least some initial ideas, and we see some ways pushing in this direction. But I think we really need to like carefully manage this and distribute this. And we need a geopolitical framework eventually for these kinds of ideas, because the last thing we want to do is like single nations deciding here alone. I think the best way to best go about is like AI chips, sure, but here are certain conditions. Here's what it means to build safe and secure AI systems. This is probably the best way I can think about it. So using AI chips maybe as a carrot, but maybe also in the worst case, maybe as a stick, depending how you want to go about it.
Sure, that makes sense. And, I think the analogy to the nuclear arrangements, I think makes a ton of sense and certainly gets my brain thinking about it in terms of from the future of those compute governance frameworks. Internationally, who do you think needs to be reviewing and updating those standards? I mean, the nuclear field grew out a whole bunch of different entities that do this, both domestically for sovereign nations and then international as well. Do you think a similar sort of trajectory is soon at hand for us in the AI space, or is there a different model that might be more effective?
I think we're moving more and more in this direction with like the UN having an advisory body on this and a group working on this with the AI Safety Institute in the UK, in the US, Japan, Canada, Singapore is also doing something. So we see more there. They don't put out regulations and standards yet. I think what they're doing is the first sensible thing to do. We're just like, what's even the problem? What is even the risk here? It's like, that's the first thing we all need to agree upon. It's like, oh yeah, actually we're worried about X, Y, and Z. I think the AI Safety Summit last autumn helped a lot with this. It's like, okay, here are some things we're worried about. Now let's like bring more detail there. So right now, I think the best standards we can set is like a standard on evaluating these capabilities. What's worrisome, what's not worrisome. And again, and then across the domain from just like labor replacement. What is it going to do to our workforce? From cyber attacks, what are the capabilities there? From up to, damn, there's going to be like a lot of synthetic media all around the world. What does it do to like our epistemics in the information ecosystem? Up to the national security risk. Can these things help with producing bioweapons or being used for cyber attacks? If we get an agreement there, and if we find something there, I think then it's just a matter of time until we agree how we manage this. So like that's the first sensible step. And then maybe these bodies will do it, some other bodies will do it. I expect in general it will be more like a way of like muddling through than of just like, here is the way we govern it, we're all good. It always looks a bit different. So we will have different bodies looking at different things. And again, we see different bodies there emerging. Another example is the Frontier Model Forum, which is then an industry body. Again, played an important role in nuclear, will also play an important role here. Are they alone sufficient? Well, absolutely not. It's an industry body. For this, we then again need like other third parties like me and others who like hold up the finger and scrutinize these kinds of things. But then we also need like maybe something on a G7 level, OECD level, then also something on the UN level. Again, every level there is like its pros and cons. Sometimes it's hard to have these discussions at the UN level where the majority of countries can't even participate or like get any benefits from AI. And all you do is talk about the risks. Maybe things are better happening at a G7 level, depending exactly what you want to talk about. And also another notion is like national security risk. You don't talk with all the countries about the risk posed to your country. That's mostly a thing you do with partner countries, with allied countries, within like the selected amount of stakeholders there. And then I'm just telling people, set up whatever body serves your needs. I'm generally a fan of talking to others. Of course, you cannot bring every topic to the table with everyone. And then just like come up with different bodies there and then do it. And again, the nuclear is to good learn from banking. We have a lot of regulations on banking, be it domestic, be it international. Lots of stuff to learn from nuclear, atomic energy, and various other international bodies where we've made many mistakes. We learn from them. Maybe we can make it better now. I'd be surprised if we don't make any mistakes, but at least let's not make the same mistakes again.
Sure. And certainly in a realm that crosscuts as much as AI does. I mean, each of those is sort of a purpose-built regulatory regimen. AI has something to say about every single one of them. So that definitely complicates the environment and the problem a fair bit. Do you see any potential tension with the data owners, the chip manufacturers? Like those are sort of going to be the currency denominator in the future. it's a different entity being regulated typically than what regulatory frameworks have gone after in the past. Do you see that presenting any sort of potential issue there, especially when the product being regulated is something that by design is really good at influencing thinking and decision making?
I think the interesting dynamic we see, it's like private companies producing most cutting edge tech. This was not the case throughout most of history. So this definitely changes the dynamics a lot, and it skews up incentives like quite a lot. There's generally the thing which we just see. Sometimes these chip designers, these AI developers, and these compute providers, they're all the same company, naming Microsoft, naming Google. Well, this brings up some interesting questions. And again, it's not a new question. I don't necessarily have strong opinions there. All I can say is like the FTC and the UK, they're looking into these kinds of things. What about this vertical integration going on there? Is there like too much market concentration? Are they abusing these kinds of power? If certain futures of AI are true, where you just expect like a massive windfall and these companies really have the impact they expect them to have, we need to do something about this. And again, OpenAI and others have certain commitments to windfall, sharing the benefits with humanity. I do think we need more detail here. And we just really need to hold them accountable for these kinds of things. So government should have like really a close eye on these kinds of things. And then the other domains here are, it directly feeds into international competition. As a country who like develops these frontier systems, you always have the problem, why should I regulate it if it's my major revenue maker? Well, of course, the Europeans might be excited about regulating the biggest frontier companies because these are only American ones, right? This might be like, in this case, to their benefit. And Americans might be less excited about these kinds of things. And again, I think you see this with this focus on national security, which is like the thing where everybody kind of agrees on. But can we move beyond that? Can we actually get like a domestic regulation framework going in the US? I think it's a key open question, which we will see like over the next couple of years, if these kinds of things will happen. And those are the things we need to have an eye on. And then just also, who invests in this? What are the structures here? Who's buying whom? Who's the AI chip design? NVIDIA is leading right now. But to some degree, this number is not 100% true because Google is also producing chips. At least they're not producing them, but they're designing them similar to NVIDIA. These are probably the second best chips on the market, they're TPUs. And most people don't talk about and have an eye on NVIDIA. And now Microsoft is doing the same. AWS is doing the same. Everybody's designing their own chips tailored to their workloads. And it makes total sense from a business perspective. But we need to talk about like the types of integrations which are going on here and what does it do to the competitive landscape. But also I'm leaving my area of expertise here. I can just point out a couple of things. What we should do about them are just question marks in my head.
It's a seductive area because it does want to pull us away from our areas of expertise because it does have such broad and far-reaching implications, benefits, consequences. What the world's going to look like in 10 years is going to be massively influenced by this. And so it's hard to keep it confined to our little box. But as a way of starting to wind up our conversation, let me just ask you this one final question here. From the perspective of a policymaker who might be listening to the podcast today, what is a key piece of advice that you would give them in terms of how to navigate the complex AI landscape and bringing it back to your area of expertise, specifically in the area of computational resources?
I think for computational resources, the thing which I would like to tell most people, it's a tool. This means, sometimes a hammer is a great tool. Sometimes it's a pretty bad tool. Sometimes it's a pretty blunt tool. So one really needs to be careful there. And I think again, guys advocating for the use of computing power, I am sometimes the guys like, well, this is not a suitable use of this tool. You really need to be careful if it's the best tool. I'm eventually interested in making cost-effective, good policies which address AI risks. Sometimes this means compute. Sometimes this does not mean compute. And every single time this means there is something around compute. There's some governance, there are people, there's policy around this. Again, sometimes these technical solutions look too good to be true because they're purely technical, but they rarely are. There's always, again, the normal policy. There's maybe less talking, less diplomacy, which makes them more attractive, but there's still one component there. So that's generally thing which I would give people. And in particular on compute. And I think then more general is the key thing we should just do right now within our government, international, domestically, just getting more insights, learning what's going on, trusting this, well, not only trusting these companies, asking these companies, what is the new big system? Can we do some independent evaluations? We want to take a closer look at this and evaluate this for these capabilities. Once we find something which is dangerous, what we don't like, let's talk about the next step. Ideally, we have something ready. But again, going back to the earlier point, this is like where we all start. What are the risks here? Can we see it? Because I do expect these kinds of risks to rise in the future. And then it's good for us to have sufficient evidence to make the argument for it. And ideally, we have the tools ready. And we have the expertise ready. The best thing which government can do is hire a ton of AI folks, hire technical people. Please keep them close, give them some money, whatever, make their life easier, reduce the bureaucracy, and make sure these guys stay because you will need them. going forward in the future. And AI is moving so fast, you need to act fast. I generally say like governance capacity. This is what I want going forward.
Excellent. Well, thank you. I like to give my guests the final word. Anything else that you would like for our listeners to hear before we adjourn for the day?
No, nothing from my side. Thanks so much for having me, Max. People are happy to reach out. People can reach me. I think we might going to be just linking my website. I'm generally available and happy to talk about these kinds of things. I also wrote a bunch of papers, like most of the things we just said here should be written up somewhere where I make the argument nicer and better than I probably did here with the right citations. Please refer to them and read more to learn more about this topic.
Excellent. Well, Lennart, thank you so much for your insights and great conversation today. And to all of our listeners, we'll see you next time. Thank you.
AI, Government and the Future is brought to you by Corner Alliance. To find out more about Corner Alliance and how we work with government to create results, visit our website at corneralliance.com. And then make sure to search for AI Government Future in Apple Podcasts, Spotify and Google Podcasts, or anywhere else podcasts are found. And click subscribe so you don't miss any future episodes. On behalf of the team here at Corner Alliance, thanks for listening.